Azure AI Foundry with Scott Nichols.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm that serves companies using .NET and Azure, and we build mission-critical software systems, rescue failing projects, empowering software delivery with a proven approach. And I'm excited to announce that my latest book is now fully released. The book is about software leadership. It's called The 5 Pillars, Leadership for Effective Custom Software. And the book is for really anyone who's attempting to make a custom software team highly effective. And if you want your team to deliver world-class results, this book may be for you. Teams are also doing book studies and discussions around it. And so I'm excited about that. We have a 7-week study guide. And if you, dear listener, would like a complimentary electronic copy of the book, then just send me an email and I'll be happy to get it to you. And for those of you who are in a lead architect or software executive role, you might want to join our monthly forums. These are interactive, deeply technical sessions that I enjoy facilitating myself. You can sign up at clearmeasure.com. It's effectively a Zoom meeting and you're surrounded by a bunch of your peers. And I've also just launched a new lead engineer live stream on YouTube. And for any software engineer looking to be successful as an engineering lead on a software project, I'll cover topics essential for that software lead role and answer whatever questions come up. So you can subscribe at youtube.com/clearmeasure. Just subscribe to the channel and then you'll be able to see the live stream schedule. And my guest today on the show, a returning guest from way back in episode 116, is Scott Nichols, and he is a principal cloud solutions architect at Microsoft. He works for the commercial enterprise division, serving the high-tech division out of Silicon Valley, and he's also the leader of the .NET and Azure user groups in Boise, Idaho. He started his career in the IT profession in 1993 as a mainframe and web developer, and since then, he's served as a lead software engineer and solution architect, software development engineering manager, senior cloud software solution architect. The list goes on, enterprise architect. And when not at the keyboard, he loves the outdoors, hunting, camping, fishing, archery, and also working in the yard. So, Scott, welcome back to the show. How are you, sir?
I am glad to be back. Yeah, it's been a long time. That was probably pre-COVID, I'm guessing, right? Or no, just right around there.
It was 2020. That's right. Yeah. A lot happened that year, didn't it?
A lot happened. The world turned upside down on us.
That's true. That's true. So I'm glad to have you back on the show. And you've been doing a lot of work with cloud, which now encompasses a lot of AI, which is scaling in the cloud. But there's so many listeners who probably have come to the Azure and DevOps podcast since you were on last. I want to kind of back up and are there any high points or turning points that were influential in actually steering your focus into the cloud and into AI?
Sure. I mean, I think the big one is obviously everyone knows, Microsoft got involved with ChatGPT, was the big, we own 49% of them or something like that. So I think at that point is what really kind of changed my personal direction and Microsoft in general, right? Where I would say Microsoft right now is really trying to dominate the generative AI arena.
Mm-hmm.
They've got the lead right now and they don't want to let it go. So every division of Microsoft, I don't care what tool it is, from Office 365 with the Copilots, Azure with generative AI integration tools now coming out everywhere. I think that's Microsoft's next big push, is being the generative AI leader in the workspace. And like I said, a lot of this all started when Satya and Bill Gates kind of demoed. It was a very early version of ChatGPT, and it kind of blew them away. It's like, oh wow, this is actually useful now, right? It's it's finally somewhat useful, and that kind of changed the direction. And like even the people that go to Build and all the Microsoft conferences, you'll pretty much see they're all dominated by AI talks. And if it's and an infrastructure guy like me, it's pretty much how do you create infrastructure around AI now, right? How do you so none of the old stuff has changed. All the stuff that we've been doing for 10, well, in the cloud, 15 years, it's like a pyramid. It's all still there. It's all the infrastructure. It's all built on. It's just now we're figuring out new ways to create these generative AI interfaces to reduce cost, gain efficiency, gain strategic IP over our competitors. Using it as the latest tool in the toolbox to, move propel our companies forward with, like I said, those kind of three pillars: cost optimization, new intellectual property, and creative ways to create new products in the solution space.
Mm-hmm. Yeah, yeah. And while you and your colleagues are focused on that, there's just a lot of people who are still trying to catch up and figure out, oh, shoot, I haven't even done any AI coding. I've used ChatGPT. Maybe I'm
Right.
using Copilot, but I'm a .NET developer. I haven't done any AI coding. What does even AI coding mean? Talk a little bit about some of the things in Azure for
And
people who've literally never even, all they've done is ChatGPT or Copilot,
right.
and they haven't even looked at AI Foundry or any of the other things that are meant to be kind of on ramps into this. What things should they look at?
Right. And my background. I'm a software engineer by trade.
Yeah.
I'm a code, and writing code is kind of our thing. But what I would say is working with the large ISVs and Silicon Valley that I work with, and I get to see their project stacks. What is their CIOs, CTOs investing in, and what they're not investing in, and almost except for the meat and potatoes, right? Cloud operations, DevOps teams. You
Yeah.
have to
Yeah.
keep your operations up and running. That's not going away. But as far as projects, new project workloads, what are the dev teams getting? It's pretty much 80% generative AI based projects, right? It's taking their solutions and figuring out, and not just the customer facing, but also internal, right? How can we use these tools to maybe have some type of generative AI process that's looking for mundane work that can save our engineers time, that can look at workflow logs and just glean. Like one of my customers, they're a networking company, where you would know the name if I told you, but they gather tons and tons of telemetry, right? So now they're using generative AIs to look through all that telemetry and figure out new patterns, and they're creating a whole new product to sell to their customers. Like, hey, since all your data ingests through this nav device,
Mm-hmm.
now we've got these advanced AI patterns that are pulling all these cool things out, and we've tied it into 10 other log and aggregators, and we're finding all this cool stuff. So the security space we're seeing is booming now with new tools, um, you know, log integrators, things like that. So yeah, from the very low level, we're seeing people use generative AI to help with pattern recognitions. From the client side, you've got the typical chat bot on steroids, but more so, I would say it's more of the smart application. Like, for example, let's say you have we have the Contoso app that Microsoft likes to use, right? We've got some pretty cool demos where you can just talk to it, right? You little the button, and it's an agent based AI. So
Mm-hmm.
there's no screen to go to. It's not really a chat screen. You're just talking to it and say, hey, can you find a pair of sneakers? Oh, great. Would you add that to the cart? Do you
Yeah.
have a blue option? You're just talking to the computer, and this generative AI engine has hooks into all these APIs, so it knows how to pull information. So it goes way beyond just a chatbot, right? You're creating a voice interface that knows how to hit the different backends to pull the data that the person is asking for, and it does really good at understanding English, understanding slang. So you don't even have
Mm-hmm.
to. It's where if you've written chatbots before, it's kind of a laborious process. You you had to do all the
Yeah.
mapping, you had to find all the phrases, and now you don't have to do that because these LMM models understand English better than we do, and they're really good at picking up slang and phrase. So it does a pretty good job of interpreting the intent of what the request is, and then on the back end, you just got to figure out, okay, here's my different models, and here's my different API points, and now I just got to connect it. And I think you were talking about like AI Studio. Well, it's formerly Azure AI Studio. It's been rebranded to Azure AI Foundry, and that's probably the primary tool now that Microsoft's giving the world to for them IT shops, develop organizations to play with, create generative AI pipelines.
Mm-hmm.
There's another one called Azure Copilot. So if you hear Copilot, that's more on the Office 365 side. You're creating copilots for that, or if you Microsoft's letting people take the brand too, you can create your own co-pilots. They're not suing people for that. But
Well, that's
if you're a
good.
developer, you'll probably spend more time looking at the Azure AI Foundry. And really all that is, it's a web portal. If you do have to spend money on Azure, so the service is free, but what it does, it allows you to spin up some Azure Compute. It has access to over 1,800 models, of course, all the chat GPTs, all the open source stuff that's out there that Microsoft could find, Huggy Face, all of Meta's models, Microsoft's new proprietary models that they're giving away. Most of them are the small language models, not the large language models.
Mm-hmm.
Microsoft's really trying to invest in the small language models, just because of our enterprise customers, they're really focusing on cost. And it's not always appropriate to use a large language model for everything, because it's a
Mm-hmm.
big honking model that's ingested the web, and
Right.
it's expensive to run, right? The
Yeah.
tokens aren't cheap. So those tools are really nice. They're pretty easy. It's very WYSIWYG in nature. You can connect it up to Azure APIM, API management, all of our API services. So it just allows you to create an orchestration. You actually just, with visual tools, you can click to any model. You can do some sample prompt programming right there. It'll send the prompt to the model. It'll come back with its message, and then you can wire it up to any API endpoint that you can think of, and then it'll marshal that workflow around for you. So yeah, we're trying to really kind of teach developers now to put in their toolkit is like, hey, we're really good at writing code, classes, models, unit tests, integration tests. Well, now learn how to write AI workflows, using generative AI tools. You don't necessarily need to become, as a software engineer, it's not really needed to be a data scientist to learn the model.
Mm-hmm.
Just what we're seeing as normal developers are just picking models, right? They can read the model, they can see what the model was developed for, what it was designed to do, and you just play with it and just you put in different prompts, you see how it comes back and say, "Ooh, that's pretty accurate," or "That's not very good." Or and I think in our other talk we had talked about RAG custom searching, right? Like tying these models also into your proprietary data, right? These models are compiled on open source data, right? So
Mm-hmm.
they don't know anything about your native business. So that's only
Yeah.
one piece of it. The generative AI with the open source models is all about understanding common data. But most people, the bang for your buck is your intellectual IP, right? If you're a medical company or something like that. So you do have to write your own adapters into your own proprietary data. But what the model can do is, if it understands English and can reason, it will reason over your own data, as well as the open source data, right? And then you can get some very unique information out that's unique to your system, right? Whatever your IP is, that's stored in your systems.
Yeah. I was kind of wowing or amusing my kids. There's 3 teenagers at home with AI Foundry and the little avatars that they have. You can make them say anything, generate little
Yep.
videos, or speak into it, and then have it translate into any of several, many dozens of languages right there on the spot. And of course, it's like, "How are you doing that?" And
Yep.
and then I installed Olama locally and with the web UI. And I said, "Here you go. Well, now we have a local chat GPT right here in the house that doesn't even run online." And
Exactly.
they're like, "Really?" So for developers who, never done anything, is it easier to kind of go through with their, Visual Studio Enterprise monthly allowance, or is it a better on-ramp to install some things locally and just get going that way?
I mean, I am a cloud guy, right? But
Mm-hmm.
I have a nice, sweet little shop here. I got servers at home. I do like having on-prem hardware and things to play with, right? It can get a little expensive when everything's in the cloud. I think Microsoft's done about as good as a job they can get with like Foundry, with giving you a $200 free credit to start with.
Mm-hmm.
But at the end of the day, you've got a computer running in the cloud. You're going to pay a little bill. They got a bunch of stuff for free that you can play with, but it's not free, right? So for developers playing around, you don't always want to pay money. So yeah, I encourage people to grab on-prem tools, open source stuff, install it on your laptop, play with it. So I definitely think that's the case, even though I work in the enterprise space, so it's always large systems and
Mm-hmm.
things, but it's just good to get the basics out of the way, right? Just play with some of the on your local laptop. Now there are some things where, like even Azure, they're doing you can deploy these edge models to your computer, right? Like we're like local little small laptops, right? So you can deploy edge systems and it runs on an edge device. And you can treat your laptop as an edge system, little Kubernetes cluster running or something in the background with the running everything.
So what tools should people be looking at for that scenario? What should they install locally?
That's a really good question because I mean, like I said, I play almost 100% in the cloud, and there are
Yeah.
a lot of open source. I mean, you mentioned a couple already that you're playing with, locally. They're probably as good as any.
Yeah, it seems like Olama seems like a slam dunk for .NET developers. Give it,
Yeah,
it just
works well with .NET.
but I'm not versed on everything that's available, and
No,
I don't think
and I don't
anybody
think.
is. It's moving too fast.
No, it's moving too fast. Even Moore's law, that 18 months with hardware. I would say in the AI world, it's more like 3 months, right? I mean, every quarter I go to an internal presentation, I'm like, oh my gosh, this is completely different now, or maybe not completely different, but the pace of innovation is insane. It's just it's moving at warp speed, and I think it's just because of anytime big business sees dollar signs, that's
Hmm.
they're putting their weight behind it, and right now big business sees huge dollar signs with generative AI, so they're just putting all the resources behind it. So we are seeing massive potential, and I think the other thing is it's finally because of the cloud and compute, and with ChatGPT really kind of getting that breakthrough model of useful, the models that they're now finally getting that 98% of translation English, like they can beat translators.
Hmm.
That was really, I saw the pivotal point, right? Like once we had a language model that could beat the UN's translators and translating languages, like, okay, now we're somewhere. And you've seen the big GPU wars going on. Oh, I should kind of mention that a little bit is, even with all this generative AI going on, not just with learning how to program generative AI and play with models and things. It's also how do you design them and scale them for your application. So there is a massive shortage of GPUs and
Hmm.
other types of chips to run these things. So even with Microsoft as big as they are, if you're customer A and you say, "Hey, we want to do this," right? It's like, and we run in Azure East US 2. Well, that's great, but guess what? We're only going to give you so many tokens. You can't run your
Hmm.
business on the tokens we're giving you. So
Yeah.
have to do a distributed model and set your stuff up in 3 or 4 different regions, and then put some type of load balancer in front of them that you can load balance your requests between capacity in different regions because there's only so much generative AI capacity we're going to give you. Amazon's doing the same thing. Everyone's doing the same thing. So it's also ushering in distributed architecture patterns for large scale companies or SaaS companies to say, hey, we just taking a thick client or a client just dump it in a region. It's not good enough, right? Because the compute is available all over and we got to go get it wherever we can, right? So
Hmm.
it's making a little more challenges for the infrastructure DevOps teams. Like, how do we write these distributed systems without making them too insanely complex, right?
Yeah. Well, that makes me think about how developers and architects should be thinking about where this fits into the .NET application. And I keep coming back. I found myself explaining it to some younger developers about the similarities with SQL Server. And with SQL Server, you have a big old MDF file, which has a bunch of data. Then you got your
Yeah,
SQL Server that's like running somewhere that is using this big MDF file that has the data. And then you have this connection string, which is how to get to it. And then you have this query, which is just a magic string that if
yeah,
it's formatted just so, you get back data. But if you run the same query day after day, you're going to get back different results because the data is
right.
always changing and people are inserting and deleting records and modifying it. But then you have the deterministic nature, where at least if it's not changing. And so I found myself explaining it that way because I found the similarities with the model being a file on disk, and then
Hmm.
the like Olama is a server. It kind of operates on it, has an address, and then you craft this special string that you send to it, and you get back.
Right.
So that kind of clicked in my head, but how do you find yourself? You travel all over to these customers. How do you find yourself explaining parallels with what they might be familiar with?
Yeah, it's actually not too hard with the enterprise developers. I mean, they're used to, I mean, at the end of the day, it's actually not very hard to integrate generative AI into your existing applications because at the end of the day, it's just a web endpoint,
Mm-hmm.
right? It's just an API call. Pick whatever form of API you're using, doesn't matter. It converts to any of it, but you're just simply making a web request to a server, and it has a prompt, and then it's going to come back and it's going to give you a heuristic, how much it thinks, how accurate it is. Or in this case, if you're talking ChatGPT, it's just giving you text back, right? So from a programming perspective, it's nothing different than we haven't been doing for a long time. It's just API programming. And then from the aggregate perspective, on top of all of these API, there's endpoint addresses, right? So you put a load balancer in front of it. You've got load balancer is going to have a unique endpoint, and then underneath it's going to load balance out to the different compute heads of the AI engine wherever it's living, and then it will aggregate it automatically. So it's actually not very complicated from programming. We don't really have to learn anything new. I'd say what's really new is understanding prompt programming, right?
Mm-hmm.
That's kind of the new thing. Is like, hey, this is just an API. We're making requests. You can use HTTPS or you can use other backend protocols. They're a little bit faster. But hey, prompt programming is kind of where we're seeing a lot of the work. Is how do you write really good prompts to get back what you want? Or like what's one I was looking at that was kind of an interesting thing? Oh, the free education company, Khan Academy. They did some really cool stuff where to help get their online tutor. So let me back up why I mentioned Khan Academy. So Microsoft gives Khan Academy free compute on
Mm-hmm.
our platform because they're complete open source. They're free to the public, and
Mm-hmm.
so since they're free, we're giving them free compute. So Khan Academy is sitting on top of Azure's generative AI platform. And they were one of our very first private preview customers of one of our offerings. But they took a good year and a half, 18 months of writing prompt engineering, a layer in between their interface and our interface so they could curate the responses, right? So when you're a tutor, or if you have an AI tutor and you want to ask about you want to make sure it gives the right answers, right? So they
Mm-hmm.
had to put safeguards in place, say, hey, if the AI prompt comes back with this, we've got to curate it. Or if somebody asks question X, we're going to rephrase that question to this because we know
Yeah.
that if we ask the question this way, the prompt comes back the right way. So they spent a lot of time in their prompt engineering in between the APIs to make sure that the responses were correct, or as correct as they could get them, to their subject matter kids, the kids asking the tutor. So that's probably the biggest thing I'm seeing. And other than that, you use a lot of search engine technology. People use Elasticsearch or indexing, Lucene search, same type of tech. It's search engine based technology. And that's what like your RAG models, right? Like when you're saying, hey, we need to index our intellectual property so the chat GPT can know what to do with it, right? Well, that's just a search index. It's just
Mm-hmm.
point it to your database, point it to your blob stores, point it to your document file libraries, and then some indexing service is going to read all of that, and then you create an API hook so ChatGPT or whatever model you're using can talk to that search engine index. So it's not a lot of tech. It's just I think what blows a lot of developers' heads is like, oh, how do I do this, right? And it's a lot of existing programming stuff that we've been doing for a long time. It's just now we're kind of wrapping it around a new outcome, right? We're saying, hey, our outcome now is some type of generative AI interface that's for an advanced search engine, an advanced agent-based system, or some type of analytics engine that's just doing some laborious tasks that we don't want humans to do, like look at NetFlow logs and find
Mm-hmm.
anything looks out of place, right? Because AIs are great at pattern recognition, right? So they can search through millions of records in seconds. So they're great for stuff like that.
Yeah, for sure. Well, with this prompt engineering, if code is calling it now on ChatGPT, you give it a sentence and it gives you like paragraphs back and you read it. But
Yeah.
if it's code, I want to get back JSON or XML or something that I can get into some data transfer objects and then operate on. What are the patterns that you think have become successful, or are there some libraries that are already out there that do a good job of parsing on the request or the response side?
On the Microsoft tool sets, everything's coming back in a JSON response object. So you get
Mm-hmm.
it back as a JSON, and then there's elements in the JSON that give you like your map. If you're looking for a search, it'll give you how accurate it thinks your search is. So you can put parameters in there that says, hey, I want to get stuff that's only back at 90% accuracy, potential accuracy. Like if you're saying, I want to look at these photos and give me a picture of a puppy, and it will
Mm-hmm.
give you back saying, we think this is a puppy and it's 98% accurate a puppy, or this is only maybe 76% accurate puppy. You can say, yeah, delete everything, it's below 90, right? So yeah, so it is pretty easy to work with because like I said, the default is everything in Microsoft land is a JSON object with text in it, and you can reason through it, look through it, and there's a bunch of metadata. So you don't just get the text response back, but there's a bunch of metadata in there that your engineers can look through and tag and filter out based on that metadata that's returned as well.
Yeah. And that's a good point that you just made about we're certain percent sure that it's a puppy,
Right.
that it's a
Right.
percent sure it's, and
Right.
everybody's seen this where they ask a question and they get a response back and they know that's totally wrong.
Yes. Yeah, and that's they call it, hallucinations, or like on the verbal stuff they call it hallucinating. Or it's kind of funny, like when you look at Wally or what is it, Dali, the one that does the generating the images, right? And it can generate some wacko stuff, right? Like even when you tell it to generate something, give it names of your building, and it'll create a beautiful picture of your building. It spells your building name wrong, right?
Mm-hmm.
Like that, right? Um, so it's getting better. So that stuff. So that's why you do have to put safeguards. You can't just wire this stuff up to your product and just turn it loose to the world. And I can say most of the companies I'm working with, we've been working on AI projects for several months, if not a year. And most of them haven't put it in production yet, right? They're still in development. They're still slow baking, rolling out. They really want to make sure it's, well, especially the public facing ones, right? They're really taking their time there. But even the ones that are kind of IT, they're more using as an analytical tools where they're reasoning over data and trying to find stuff. They're taking their time. They want to make sure there's a real value add here. And the real reason is, what's the error? We know that there's going to be an amount of an error ratio there.
Mm-hmm.
What is that error ratio? Can we get it to acceptable levels to get the noise out? And what kind of prompt engineering can they do to reason that down to acceptable levels? And because as time goes on, the models are going to get more powerful, and not just the models. There's some new techniques like the Microsoft's the agentic-based AI programming, meaning everything's agent-based, and they're going to have agents monitoring agents. So we're talking about the accuracy of the prompt response back, right? Well, now you can actually have an agent that's almost like a pair program, right? So as the prompt comes back, there's going to be another generative AI prompt that's going to analyze that data, that response, and check it again, and it's for accuracy, right? And say, I just ran the original question and I didn't get that back. So it's almost like a quorum thing, right? So we're trying to come up with ways now to have AI agents monitoring AI agents just to help validate some of these dumb responses sometimes it gets back, right? It loses track of like like ChatGPT is a good one, right? If you're talking with ChatGPT and you're 4 levels down the prompt, right? Sometimes it loses context,
Mm-hmm.
and it's like, no, I was talking about X, and you just jumped, completely lost my context, right?
Yeah.
So with this agent in the background, it knows that because it's keeping state of that, and it's like, oh, that's a wrong response. Try again. And so they're coming up with new techniques to make these more accurate. Again, it's not intelligent, but try to make it more intelligent, right? It's the facade of artificial intelligence. These are really just pattern recognition engines, and they really don't have any intelligence. That's kind of the funny thing, right?
Yeah. One of the fun prompts that I encourage people to do is when they are testing out a different model, just send it the prompt. What are you very bad at? What are you terrible at?
Yeah.
What do you get wrong? Like, and it'll actually generate some pretty condemning things.
Yeah. And there's
Although,
things you can see, like from an IQ perspective too. Like ask ChatGPT, like here's one that it will not get right. You can ask it, I'm going to hang my clothes up on a clothesline to dry,
mm-hmm.
and it's going to take 3 hours for my clothes to dry, and the wind is blowing at 10 miles an hour. If I increase the wind by 20 miles an hour, how much, these word type problems, it doesn't have enough abstraction to figure it out. It's just going to do a simple multiplication with the wind and the hours, which is wrong, right? It's like, okay, the wind goes faster, the clothes are going to dry, dry faster. It can't figure that out. It doesn't understand that. So you do have to. So what I'll tell people is you do have to test, and then when you find situations like that, that's kind of like what Khan Academy did. Thinking of their math and physics, it couldn't reason over some of the physics questions, right? Because it just didn't understand those logic loops. So they had to write prompts. Say, hey, when we ask this type of question, we have to rewrite the question this way, so the physics engine will give the proper response on just a complicated wind temperature type thing. So.
Mm-hmm.
That's a very real thing, and that's why some of these things are taking a little longer to roll out, than people think. I think we are over the hype curve, my personal opinion. Some people are very skeptical. It's just where I sit, I'm seeing too many projects that they're showing a lot of. I mean, it's impressive, right? I've been very, very impressed with the generative AI projects coming out of Silicon Valley companies. That they're doing some amazing stuff, right? Are they prime time? Probably not yet, but by the end of this year, these are going to be very viable products that they're going to make a lot of money on,
Hmm.
or just going to reduce their costs because they're able to reduce a lot of waste or give new services to their customers just by having generative AI reason over their data that they already had that they
Yeah.
just didn't know before. So I do see that, and that's why I understand why all the CTOs in the world are starting to really invest in this. Is they see the writing on the wall. I think I mentioned this in our little meeting we had the other day. Is if you don't invest in generative AI and you have a large customer competitive base, you're probably going to get moved past by, right?
Hmm.
And even the big companies that are big slow boats, well, they're looking. Well, we're seeing a lot of acquisition and mergers going on right now, right? Google, Microsoft, they're the obvious ones. They're always buying up and sucking up IP, right? But we're seeing a lot of different mergers. So I do see a lot of consolidation. We do see a lot of companies failing, right? There's a lot of companies that are startups in Silicon Valley, and they're dead. They start, they die, right? There's a ton of because everyone's trying to jump on the bandwagon, right?
Yeah.
But there is. So I think we're definitely over the hype. We have the compute power. The models are strong enough to do some interesting things. So we're it's not all vaporware, I guess is what I'm saying right now, right?
Hmm.
Microsoft, Facebook, others, they're all creating their own tooling packages now to make it easier for developers to introduce generative AI into their software stacks. So we're trying to get the tooling better. That's been really rough, right? When I say tooling is important because writing search engine technology is not easy. I don't know if you've ever
Hmm.
done listening. I mean, it's not an easy thing for
No.
software to write a big complex search, and that's why Google won the battle, right?
Yep.
They were able to figure out how to write the best thing search engine on the planet. So it ain't easy. We know how to do it, but it's not easy programming. So I think that's why, like Microsoft, Facebook, some of the others they're really trying to focus on tooling right now to gain the software engineering market, right? And I think they're going to be very successful, right?
Yeah.
Just make it simpler.
Well, Microsoft's always been really, really successful at putting out good tools.
Yeah, no, I think that's they bought GitHub, and they're going to be a force to reckon with. I mean, I may work for them, but at the same time, I see the competition and I see
Yeah.
where the leadership is going with the company. And it's like GitHub was a brilliant purchase. Giving away Visual Studio Code, brilliant, right? It's the number one editor on the
It
planet right
is.
now.
Yeah.
Uh, so Microsoft is very much still in the tooling. That's kind of they
Hmm.
understand if they can win the minds and hearts of developers, it's going to be a huge thing for them winning big chunks of business because they still understand how important developers are.
Yeah.
So that's one of the reasons I still stay there.
As we kind of wrap up and come to a close, besides the regular unit tests of my local code, is it the same integration testing patterns when testing code that calls out to this API in
Yeah.
Azure and having development? And what does that look like, or what are there new patterns in there?
No, that's the beautiful thing is because these are just web services. There's nothing different. It's just the endpoint's a different endpoint. Uh, they're more integration tests, I would say, instead
Yep.
of
Yep.
unit tests. So
Right.
but integration tests can still act like a unit test. You can still run those integration tests, and you want to see a expected response back. So you can still put that hard check in and say, "Hey, I'm going to send this prompt, and I expect a response that looks like this, and
Hmm.
it needs to match." And so you can still have those, right? And I will mention though, as this is because with real AI, you really can't do it locally, right? I mean, you can, but most people are going to be using some type of cloud service, things like that. Um, Integration tests are becoming more important. Chaos. Have you heard of Chaos Monkey?
Chaos
Chaos
Monkey
testing.
from Netflix. Yeah. Long
Yeah, so
ago.
that's becoming a much bigger thing in my world is teaching people that say, hey, your distributed networks have to be more complex now because we have to spread work around and
Hmm.
developers are really good. They understand unit tests and integration tests, but now we need to put this thing called chaos engineering in the mix, right? Because you now that you've got your distributed across three, multiple zones, multiple regions, we've got to figure out ways to make your stuff more durable. So that we're kind of adding that test, probably I'd say more to the DevOps crew, more
Hmm.
kind of stuff. The developers don't have to deal with it too much, but DevOps engineers, it's kind of a big part of their world now, chaos engineering.
Yeah. If you have to distribute, well, then you have to test what happens when one of those regions or something somewhere is not accessible or starts having
Exactly,
problems.
right. Yeah, break a core router, take off one of your primary database nodes,
Hmm.
break one of your primary replicate storage accounts and see how your system responds, right? And then engineer around it. And then what a lot of people don't realize is software engineering does have to get involved. So for example, like,
Hmm.
hey, you've got a distributed system. you might have to actually put code in the software stack that says, hey, try this connection first, then this one, then this one.
Yeah.
And retry logic, right? Or caching is a good one, right? A lot of people say, yeah, we use caching. Great. Well, what happens when your cache fails? You need to fall back to the database, right?
Right.
Well, I'll talk to your software developer because they got to put that hook in the software.
Yep.
Right. So it knows what the alternative connection is instead of leaving it to the infrastructure, the DevOps engineer to figure it all out, which is hard because most of the code is locked up in a container and they don't have access to that. Right.
Yeah. Yeah. For sure.
So there's a lot of so it's our jobs haven't gotten easier, and I'll say is people think this is going to put software engineers out of a job. I'm going to say not even close.
Yeah.
If anything, it's making our jobs fun again. It's exciting. We are the puppet masters. We're the orchestrators. It may get rid of some low-level stuff that we don't have to do in the future, but at the end of the day, you still need a software professional to orchestrate it all together, to test it, to harden it, to have the master design of what you want to put together. You know, we're the software is our canvas, and we are the painter, and that's not a way. Even though we hear stories of, hey, my team's X% more productive. True, but we've been in a shortage of programmers for decades now, right? So, but that's when my people fears like, oh, we're gonna lose. Nah, we're fine, and then companies are just figuring out better ways to utilize their programmers now, right? That's all.
And developing more software than ever.
No, and that's it. We're seeing more software, more things, and this AI revolution, I think, is going to bring. You hit the nail on the head. It's putting more stuff in the software stack, right? It's putting more stuff in the software ecosystem, right? More intelligent computers is because now you can get rid of a lot of humans that did a lot of mundane tasks, and you can just have the simple the AI chatbot, kind of reason, and it does for simple tasks. It does fine. Like help desk is another good one. We're seeing a lot of help desk programs. They're using generative AI. They're not getting rid of help desk staff. They're just saying, hey, the simple question of asking the generative AI robot, how do I log in? It can handle that. And the complex questions are going to the humans, right? So the humans they're taking on the harder tasks. And then we're just trying. So it's not that all the humans are going to go away, but it's just the jobs that the humans are going to have are going to be the harder ones, right? Because the generative AI will do the robot, which maybe some humans might like that, so.
Well, that's the way it's always been. As we develop better machines,
right.
The things that can be done by a machine are.
Yeah, no, people get afraid, but I mean, Jeffrey, you've been doing this as long as I have. Is like I've been putting humans out of work for 35 years. We've been automating things with software forever, so this is not new. It's just another wave, and I think the biggest thing now is I think in my past I've been putting a lot of blue collar workers, automation. I worked at Micron and Intel for a while, a long time. That was manufacturing automation software, so we automated blue collar workers out of jobs with software. Yeah. Now, what I see generative AI doing is it's more of the white collar, right? Because it's a knowledge-based field. Now it's the lawyers and knowledge-based workers. They're taking their cut, right? So we're hitting them a little bit because we're taking the mundane things that these AI engines can do. Simple questions, right? Like I said, they're not smart, they're not intelligent, they're just pattern recognition engines. So, but it is going to be real. I mean, it is real. I do wonder, like everything, right? We always have to adapt. Like I said, 15 years ago, I used to work at fabrication sites with 3,000 people per site. Now there's 16 because we've automated with robots. Those people had to do something else. So the knowledge worker fields are going to have to adapt too. But we'll have to see how that goes. But at least for our ecosystem, I would say it's a great time to be a software engineer. It's really exciting. I'm seeing a lot of innovative projects, interesting things that people are doing. And I would encourage software engineers, DevOps engineers to learn about it. Because like I said, almost 80% of all software products I'm involved in has a generative AI component. Yeah. So I would just think just being selfish from keeping yourself employable with a high salary. If you want that high salary and be employable, you want to know where the market's going, right? And if you can jump on the bandwagon early, you obviously can keep yourself at the top of the game, right? Yeah. So I would just say, and like when I speak at colleges, that's what I tell kids, like, hey, if you ever want to surpass the 25-year veteran that you can never be, just look for the next new technology coming and become an expert. That's and you'll leapfrog that oldie moldy in a day, right? Right. People don't care if you're a junior engineer if you can do the work.
Right. For sure.
They don't.
Absolutely.
So yeah, I think I would say to your audience, I'd say use this as an opportunity for those who are hungry and want to pole vault their career. Learn the skills, get into it. These are the early days, right? We are in the early days of this. So I would say if you can get your head into it, it'll keep you going for the next decade.
Yeah, I agree. And all right, so ai.azure.com is a good entry point if you just want to put in one URL. So, Scott, thank you for coming back on the podcast. I really appreciate it. This is a great conversation.
Glad to be back.
Awesome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.